Today we're dealing with areas of parallelograms and triangles. And I know you're thinking, hey, Mr. Etzel, we're in geometry now. I already know how to do a parallelogram and a triangle. Well, I got you because you learned this stuff in like 6th grade. But we're going to start using some of the things that we've learned in geometry and algebra to apply to our parallelograms and triangles to help us solve. Okay, so it won't just be straightforward and just be given a base and height and solve it. We'll have to think a little bit. So just a quick review. Area of a parallelogram is the base times the height. So here's the symbols. Area equals base times height. I could write it out so we can see it. Area equals base times height. Times height. And that was derived a while back in 6th grade, because remember, if I had a parallelogram right here, and I took off this little piece, this little triangle right here, if I cut that off and brought it to the other side, now I just made myself a rectangle. So in a rectangle, the area is length times width, which is really just your base and the height of your parallelogram. That's where that base times height comes from. So hopefully we still remember that. So we know that area of a parallelogram is base times height. And for a triangle, it's just half of that. Okay, because if I think about a rectangle, if I were to cut a rectangle in half, its area would be a triangle, right? So now it's 1/2 base times height, which we can see right here. Or you can take the base times height and then divide by 2. So things you've dealt with before, but now we're going to apply some of our properties and theorems in geometry to help us out. So let's look at a couple examples. It says find the perimeter and area of the triangle. Round to the nearest tenth if necessary. So let's take a look at the perimeter first of all. Perimeter, well, distance around the triangle. So if I look at my little skinny triangle here, I got this side, which is 21.5. So we basically just add up all our sides. Plus this side, which is 5. And then for the last side, right here, I'm going to have to figure that out. So take a look closely. You're given some other information. Can I use that to solve for that side? Sure. Take a look at this 8 and this 15 here. It looks like it just made us a right triangle. So I can solve for the hypotenuse over here. So now we got to apply our a squared plus b squared equals c squared. So we got 8 squared plus 15 squared equals c squared. So 64 plus 225 equals c squared, which means we got 289 equals c squared. And to solve for c, we take the square root of both sides. So the square root of 289, which I believe is 17. So c equals 17. So I know that this third side right here is 17. So I got to add 17 as well. So it looks like the perimeter is going to equal 21.5 plus 5 plus 17, which gives us 43.5. And we need a label. It's just a distance. And what distance are we dealing with? Inches. So 43.5 inches for the perimeter. Good so far? All right, let's take a look at the area. Well, we just talked about the area of a triangle is 1/2 base times the height. Or base times height divided by 2, whatever you like to do. Well, do I know the base and the height here? So 1/2 base. This is kind of tricky. It's just the base of the triangle. So whatever I decide to be the base. So right here, here's the base of the triangle that I want to choose. It's not this entire thing, okay, because that's not a part of the triangle, that 15. Just that 5 inches is a part of the base. So 5 would be the base, and the height would be, remember, for height, it's got to be the vertical height. So from the base to the top of the triangle. Well, that's why they drew this thing over here, because here's the vertical height. From the base of the triangle, which they just extended out, to the tip of the triangle, it's vertical height, so 8 inches. And then let's just apply our associative property, commutative properties here. I'm going to take half of 8 right away, which is 4. And 4 times 5 gives us 20 inches, and it's area, so inches squared. 20 inches squared. So there we go. So just using some new things to solve for our triangles. How about this? Find the area of the parallelogram PQRS. So for area, a of a parallelogram, I'm going to go ahead and write my formula. Base times the height. Well, I got my base, got my 12. Let me go ahead and write that over here. Area equals 12 times the height, which I don't know. It's h. Well, to attack this, let's just start writing things that we know. Maybe fill in some things that I know. Well, let's see. I know the bases, the opposite sides are congruent. So I know this is 12. I know this is 9. Looks like I have a little right triangle here. So do I know what this distance is, that little piece? I don't know for sure, so I can't use Pythagorean theorem. Well, let's think about it. They probably gave you this 45 degrees for a reason. Well, it's a right triangle, right? If I know an angle measure of a right triangle and at least one side, which I do, I know 9, there's a couple things I can do. The one thing for sure is I could use my trigonometry. I could go ahead and use SOHCAHTOA. I could think, I want to know the opposite, and I know the hypotenuse. So which one's the opposite and hypotenuse? That would be our SOHCAHTOA, our SO, right? So I could say sine of 45 equals opposite over hypotenuse, and I could solve for h. Okay, I'm going to get a decimal, and I'm going to have to round that. Is there something else I can do? Think back. Well, let's just finish this out. I can multiply by 9 on both sides, right? So I just take 9 times sine of 45. Well, what else could I do? How else could I solve this guy? Just think, it's a right triangle. It's got a 45-degree angle. So think about what else you know on this triangle. Well, this also, right here, has to be 45 degrees. So isn't that a 45, 45, 90? 45, 45, 90. And if we remember, the legs are x's. The hypotenuse is what? X root 2. So in this case, I know the hypotenuse. So what do I have to do to find the leg? So look back here. Hypotenuse going to a leg, we divide by root 2. So to find h is 9 divided by root 2. So I could simply use that. 9 divided by root 2 for my height. Okay, because if I do the trig ratio down here, I get a decimal and it's not as exact. So I'm going to use that 9 root 2. So 12 times 9 over root 2. Well, 12 times 9 gives us 108 over root 2. So now I got a couple options. It doesn't say to round or do whatever. So I could just divide by root 2 and say the area is approximately 76.4. We don't have any units, so I'm going to say units squared. Or I could be exact if I wanted to. Right, I could write this in simplified radical form by multiplying by root 2 over root 2, which would equal 108 root 2 over 2. And I could simplify the 108 into 2, because 2 goes into 108 54 times. So it's really 54 root 2 units squared, to be exact. So in this case, since I'm not asking, I'm okay with either one of these two answers. Either one of those two answers. And even if you used your trig ratio, I'm also okay with that, right? I'm not going to be too picky here, just as long as you know how to solve for that height. So what you want to take out of this is really look at how you can solve for that missing information. So I needed the height. I noticed I had a right triangle, and I was given an angle measure. So that means you're using a trig ratio or your special right triangle. Lastly, you could be given some unknowns. So for example, the height of a triangle is 7 inches more than its base. The area of the triangle is 60 square inches. Find the base and height. Okay, a lot of stuff here. It's always good to write things down. So it says the height of a triangle, so h, is 7 inches more than its base. So if the base is b, it's 7 inches more than that. The base, I don't know. And then it says the area is 60 square inches. So there's some information that I know. Well, I'm dealing with a triangle, and I have its area. So area of a triangle is 1/2 base times height. So now I just go ahead and I plug in the things that I know. So I got 60 for the area equals 1/2. I don't know the base, so it's still times b here. And I got this for the height. So I'm going to plug this in for height there. I'm going to put it in parentheses. Anytime I plug something in, put it in parentheses. Okay, there we go. So a lot of things I could do here. I could distribute this half b to both terms. And that would be fine. But it gets a little sloppy. So I got 1/2 times the base times b plus 7. So since this is all multiplication here, I don't like dealing with this fraction. So how do I get rid of this half? How do I move it to the other side? Well, I can multiply by 2. Well, if I do that to one side, I have to do it to the other. Because 2 times 1/2 is 1. So they cancel each other. And over here, 2 times 60 is 120. I think that's going to make it a lot easier for us. Because I'd rather distribute just a b than a half b. Because if I watch what happens, I got b squared plus 7b. Because b times b is b squared, b times 7 is 7b. And this is much easier to solve for me. Because if I have a half b squared, that's a messy quadratic to deal with. And if we take a look, since I have a b squared, I have a quadratic, so we want to get this guy equal to 0. So I'm going to subtract the 120 over, subtract the 120. And we're left with 0 equals b squared plus 7b minus 120. So I could use the quadratic equation, right, because that works for all quadratics. But since there's no coefficient on the b squared, I'm going to go ahead and see if I can find factors of negative 120, factors of c that add up to b. So factors of negative 120 that add up to 7. So I'm going to just take 120 and I'm going to start dividing it by things. And my first guess, I divided it by 15, and it worked out. So 8 and 15, one of them has to be negative. And I'm looking for a positive 7, so that means I need a 15 and a negative 8. So then we write this in factor form. So 0 equals b plus 15 and b minus 8. And then I solve each of them individually. So a negative 15 would make this guy 0, and an 8 would make that guy 0. So b equals negative 15 and 8. But can I have a negative distance on a triangle? Nope. So I know it's not that. So I know the base has to be 8 inches, which means the height is 7 more than that, which is 15 inches. Right, looking back up here, 7 more than that. So there we go. It takes a little bit of work. So you just never know what you're going to use. You might use something that you learned in algebra. You might use something that you learned in geometry. But just go back in that knowledge that you've learned so far, and you might have to apply some different things. And there you go.